outcome of module 1 is the analyst would have collected all the requirements from the client. So what exactly the client wants in the software product. So all the required features, functions would be given by the client to the analyst. The analyst would have collected it and documented it in the form of a document called as SRS. We had seen that. So this SRS contains detailed, meticulous documentation of what exactly the client wants. So we have requirements organized as functional and non-functional requirements. We had seen this in module 1. So functional and non-functional requirements. Now this was module 1. We concluded with requirement engineering where this is done. And once we are done with this, we entered into module 2. In module 2, a brief overview was given in the previous session. So what is there in module 2 we had understood. So once done with the SRS, we are not directly starting with the code. So based on this requirement, we are not directly going into the coding aspects. We are not directly going into developing the software so that this software can be given to the client. We are not doing this. We are not directly going into this stage. Okay. Instead, we have one more stage here called as design. Okay. So this was introduced in the previous session. We have a design where we exactly come out with the planning and strategy regarding how the software should be developed. So we have planning here. We do the required planning for how the software should be developed. And once done with this planning and we have the blueprint, so we go into the coding part. Then we move to the coding part. So meaning that once you collect the requirements from the client, you are not directly going into the coding aspects. Instead, we jump into the design part. Okay. And how to do with this design? How we go with this design? A brief introduction about this was given in the previous session where we understood one of the most popular and widely accepted design approach, and that is object oriented. So object oriented design. So introduction to this was given in the previous session, in session 1 with respect to module 2. Okay. Now what is object oriented design and what does it mean in software engineering, and what are its benefits? All those things were explored in session 1. So we will give a few more detailing into it, few more aspects of it will be covered in this session. Okay. So the very first topic here is characteristics. So characteristics of object oriented approach. So as mentioned, for design we will use OO approach. OO is the short abbreviation of object oriented approach. So object oriented approach is for designing. Okay. Coming out with the blueprint with respect to what plans we have for the software. Okay. Now what are the characteristics? So the first characteristic of object oriented approach is objects having identity. Okay. Try to identify the objects with unique identity, which are nothing but entities. Now once again, where exactly it is done, how exactly it is done. Okay. So as mentioned, we have the SRS. SRS is nothing but a requirement document. From this SRS, we do something called as OO analysis. What is this OO analysis? OO analysis is identifying real world objects from the requirements document. So we have the requirement documents in the form of SRS. So identify real world objects. A few examples were taken in the previous session just to give you an overview of what exactly is object oriented approach and how things are happening. Okay, a few more detailing will be added in session 2, that is in this session. So we will go into specific details with respect to different aspects here. Okay, now what real world objects are identified? To understand this we need specific examples. Okay. So one of the examples I had taken in the previous session, that was the patient monitoring system. Okay, so the PMS, the patient monitoring system. If you consider the SRS of a PMS, okay, so the SRS of a PMS, and if you are trying to identify the real world objects through OO analysis, okay, what you will be identifying? So this was briefed in the previous session. So SRS of a patient monitoring system, that is PMS, just write the abbreviation here, the patient monitoring system. Okay. So what real world objects can I identify from this SRS? What I can identify? Okay. So from a PMS I can derive maybe doctors, patients, vehicles, or drugs or medicines. See, these are few real world objects that are present in a patient monitoring system. Okay, so these things are identified in what we call as OO analysis. So that is identity, the very first step or first stage, which is the characteristics of object oriented approach. This is how we follow. Okay, once done with the identification of real world objects, the next step is classify them. Okay, second step, classify. Okay, how to classify? See, classification is done based on the similarity. Okay, now in this specific example, can you group similar objects or entities? Okay, yes, definitely I can do it. This was briefed in the previous session. I have taken the same example so that we can improvise on the clarity here. Okay, maybe doctors and patients, I can call them as group 1. Drugs, medicines, maybe group 2. And vehicles I can claim as group 3. This is my classification. See how the classification has been done. See, classification has been done based on similarity. See, doctors and patients are human beings. Okay, so with that criteria I have grouped them into group 1. Vehicles are non-living objects which can move. Okay, I have put it under one group. Drugs, medicines are used to treat the patients, so group that has been put into a different group. See, please note the grouping has been done based on the similarity of the entities. See, doctors and patients are more similar to one another, okay, maybe compared to a vehicle. So that is why vehicle is in a different group, doctors and patients are in one group. So that is the second step, that is classification. And once done with the classification, grouping, we form classes out of it. Okay, for example, for doctors and patients, we can create a class, maybe class person, because they are human beings. Okay, I can create a class by name class person, where doctors and patients can be accommodated. Okay, so group 1 is under class person. Now each class will have what is called as attributes. Okay, attributes and few operations. Attributes and operations. Okay, what may be attribute for in this case? Okay, the doctor, it may be a doctor or a patient. He will have a name associated with him. Okay, you may have a mobile number. So what are the few operations, actions that could be done by these entities in group 1, which belongs to class person? So as briefed, so they can maybe walk, they can sit. Okay. So please try to observe entities or objects which are closely similar has been put in one group and it has been labeled under one class. And for each group, for example group 1, we have identified few properties or attributes which may be common among all these entities, all these objects. Also few operations, few actions that could be done by these entities. In similar lines, we can have class vehicles. So we can have the vehicle class with the same set attributes and operations. What are the attributes for a vehicle? An attribute can be, maybe vehicle can have a name, some model, color. What operations it can do? Maybe it can move, it can turn. Okay, so these are few operations common to all the vehicle. Okay, it may be an ambulance in hospital, it may be a car of a doctor, it may be a two-wheeler of a patient, whatever it is. So these things can be done. So this is what we have done. Once you identify the real world objects from the SRS, group it based on the similarity, and once you are done with the grouping, form the class, put them under different classes. Okay, this was one example. I would like to give one more example, because examples make things clear, examples help in improving the clarity. So I would like to take one more example. Okay. So maybe second example may be a college management system. I will call it as a CMS. Okay. So it is college management system. So if the analyst has come out with the SRS for a CMS, college management system, now what may be the real world objects that may be identified during OO analysis? What may be the objects in a college management system? Okay, so it may be typically professors. Okay, so maybe students, even HODs, principal. Okay, maybe classrooms, maybe chairs, desk, computers. Please note, these are the objects, real world objects that have been extracted by the analyst from the SRS during OO analysis. Okay, each and every entity that you are seeing here, each and every entity is a real world object. Okay, we have identified it. Identification is done. Once done with the identification, what is the next step? The next step is you need to classify it. Classification should be done. And how exactly classification is done? Already we have seen it in the previous example. This is a second example just to improve on the understanding. Okay. Now, for classification, as already mentioned, we should group the objects or entities based on the similarity, based on the closeness. Okay. Now, who is more similar to one another? Maybe professors, students, principals. Can I put them into one group? Yes, I'll call it as group 1. Even HODs, okay, we cannot exclude HODs here. Maybe this is one group. Okay, professors, students, principal, HODs. Okay, I put it as one group. Okay, maybe classroom, desk, chair. Okay, even computers. Okay, so that I will put it in group 2. I'll call it as group 2. Now classification is done. Please note, classification has been done based on the similarity of the entities or objects. See, a desk is more similar to maybe a chair, a non-living object. Student is more similar to a professor. They are human beings. Okay, they are people. So once you group the objects or entities, so we are aware of what should be done as the next step, next stage. Form classes out of the group. Okay. Now I will take group 1. What class I can come out with group 1? So professor, students, principal, HODs. If you just do a basic analysis, you will understand all these entities are human beings. Okay. Same, I can call them as class person. I will put everyone under a class person. Okay. Can I identify few properties, few attributes? Okay. Can I identify few attributes which are common to everyone? It may be a professor, student, HOD, principal. Can I identify few things which are common among all the entities? Definitely. It may be a professor, it may be a student, it may be a HOD. They will have name. Okay. No issues with this. Definitely they will belong to a specific age. They will have an age. They may have a mobile number. Okay. So the point here is, attributes are something that is common to all the entities here. Okay. Also, they can perform few activities, actions, okay, which we call as operations. Okay, which can be common to all these entities. Some operations, some actions can be common to all these entities. What is it? Okay. So maybe they can walk, they can come to college, okay. So these are few activities that is done by all the entities here. So it may be professor, student, HOD or principal, they need to come to college. Okay, that can be one activity which we have put under operation. So that was group 1. I have labeled group 1 as a class here, class person. And similar lines, my group 2. Okay, this is my group 2, which has chairs, desk, classroom, computers. Maybe I can call group 2. So I label group 2 as a class infrastructure. So what is the infrastructure that we have in the college? Okay, we have classrooms, we have desk, chair, we have computers. That belongs to infrastructure. Okay, it can have their own attributes and operations. So the bottom line here is, once we are done with the SRS and we enter into the design, the first major aspect here is try to identify the real world entities or objects from the SRS. Okay, that is the first stage. Once you identify the entities, group the entities which are similar to each other. Okay, classify it, and once you are done with the classification, give a class label and identify appropriate attributes and operations which are common to all the entities in the group. Okay. So this was regarding forming the classes from the group, that is from the classification. Now what is the use of this? We have come out with classes now. Okay, so we have created classes. Now what is the use of this class? For example, I have created a class, just now I created a class by name class person. Okay, so I created a class. I mentioned few attributes like name, age, maybe so designation. Also we claimed few activities like coming to college. Okay, taking breaks. Okay. Okay, we have a class by name person. Please note this class is for the college management system example that I had taken, the CMS, college management system. I came out with a class. Okay. Now what is the use of this class in object oriented approach? See, for a class that has been created, we can have something called as objects. Okay. Created at runtime, which can be manipulated, which can be operated upon to obtain the desired results. Okay. Now this was a very general definition. To become more specific, to improvise on the clarity, we will take some examples. Okay. Now for the class person, okay, I will create an object by name, for example, Anil. So person is a class here, Anil is an object. Okay. So Anil, which is an object, is an instance of a class, meaning that whatever attributes and operations are there in the class can be taken by Anil object. Okay. Please note this object Anil is associated with the class person. So whatever is there in the class person, whatever attributes are there, whatever operations are there, so can be taken by this object, by Anil. Okay. Now what will be the outcome of this in the memory when you execute this? Okay. So now Anil object will be formed. Okay. Whatever is there with the class associated with the Anil object, everything will be copied to this object. For example, name is there, name will be copied here. So all these attributes will be copied here to this object. Age is there, it is copied. Designation is there, and also all the operations will be copied. This stuff is also copied here. Anil object is created. So these are the attributes. So name, age, designation are the attributes here. Okay. So it is an attribute. Now from where the Anil object got these attributes? From where it was able to take this? So Anil object was able to take these attributes from the class to which it is associated. Please note, Anil object is associated to the class person. Okay. Because of which Anil object could take all these attributes. These attributes could be taken there. Not only attributes, even functions. Now is it that Anil object will just take the attributes? No, these attributes can even take the values. Okay. For example, name is Anil, age is maybe some 20 years, designation is equal to maybe student. Please note, this class person was a class designed for the college management system. So we have an object by name Anil who is a student. So we created one object. Now the question is, like this, how many objects you can create? Is it, this was the first one. Like this, how many you can create? Is it 2? Is it 10? So the answer to this question is, it is infinite. You can create infinite objects like this from a class. Class will become a blueprint here, using which you can create infinite number of objects, and that is the power of object oriented design. There is flexibility and scalability here. Okay. So he created Anil. Like that, I will create one more object, maybe for example Sunil. Okay. So I can place the object here itself. I mean, different programming languages have different formats, syntaxes. I'll write it in a general form. So Anil, comma Sunil. So now the second object is created. My name is Sunil. Please note, Sunil object is associated with the class person. So immediately when you specify Sunil as an object of class person, so memory will be allocated for this. All the attributes in the class person will be carried to Sunil object. So the attributes include name, age, maybe designation. So name here is Sunil, age maybe we will claim it as some 30 years. Designation is assistant professor. Okay. So operations. Please note we have created a second object by name Sunil, who is working as a faculty in our college management system. See, like this you can create hundreds of thousands of objects. So in a typical college, thousands of students will be there, faculty will be there. So you can create objects for each and every entity, real world entity, and give associated attributes and values. See, this part of the object that you are seeing, this we call as values. Okay, this is values. For example, Anil name. Name is an attribute. So Anil is a value. Age is an attribute. 20 is the value. Now what is your observation here? Now can you see one of the powerful features of object oriented design? Yes, definitely. It can be easily visualized. Create a class, and for a class you can create hundreds of thousands of objects. Okay. Easily scalable, flexible. So this is the power that is there in object oriented approach, and that is why it has become so popular and widely accepted, and that is the reason majority of the programming languages that you can experience in today's world is based on object oriented mechanisms. Okay. So as I had mentioned in the previous session, see, if your design itself is based on object oriented principles, okay, so taking a transition to implementation will be very easy. Okay, that I mean the life during implementation will be easy, because see, our complete design is object oriented. Okay, so that is one of the major benefit that I had highlighted in the previous session. Okay. So this is one of the characteristics of object oriented approach. Okay, you can create objects, hundreds of objects for a class. And the standard definition for object is an instance of a class, okay, taking the attributes of that particular class to which it is associated. Okay. Next we will see one more important characteristic that you find in object oriented approach, which is very much beneficial in design and implementation. Okay. So what is that approach? So that is the approach of inheritance. What is inheritance? Okay. So in inheritance we have something called as a hierarchical relationship. So hierarchical relationship, what exactly is that? I'll continue with my previous example where I had created a class by name person. Okay, I had created a class by name person. This class person had a few attributes like maybe name, age. Also a few operations were there. We will not bother about the operations as of now. This is my major class, main class. Okay, I'll even call it as a base class. Now from this main class can I create some subclasses, but the subclasses that I am creating should have an influence or should have been derived from the main class. Okay, this is my base class or main class. Can I create subclasses? From what? From the main class. My requirement is few things that are there in the main class should be carried to the subclass, and few things should be added in the subclass. Okay. To become more specific, we will try to explore it through example, because theoretical philosophy may not make things clear. I'll directly take an example. Okay. Considering the college management software, okay, so we have class person. So already while identifying the entities, I had made a few things clear. Person can be maybe a student. So what do you mean by this? So in the college management system, or in a college, typical college, it may be engineering college, a degree college, whatever it is, there will be students. Okay. So students will have name, age, but I am not repeating it once again here. I am not writing it once again. The reason is it has already been mentioned in one of the main classes called as class person. So I will not be writing the name and age part. Instead I will take it from this. I'll copy these attributes from the main class, and few things that needs to be specifically added here in the subclass, I will be writing that. For example, what are those specific things that are unique to a student? Okay. For example, if you consider the VTU college system, we have USN for the student. Okay. Also for a student we have uniforms. Uniforms are there for a student. Okay. Also student, these are few attributes. Please note, these are attributes that have been added in the subclass. Which subclass? Class student. Class student is a subclass of which main class? Class person. Okay. This was student. So we can have maybe one more entity here. Okay. One more subclass. So maybe class, a professor. Since we have taken the college management software, so class professor can be one more entity. Now what are the things that can be unique to a professor? See, a professor will have name, age, fine, but it has already been mentioned in the main class, so no need of writing it once again here. Okay. Some things that are unique to a professor, maybe you will have an employee ID. Okay. I'll write it as EID. Okay. Employee ID. Since professors will be paid with salary, they need to pay the income tax, so obviously they will have a PAN number. Okay. Now what are the operations that are unique to a professor? Okay, maybe a professor will be teaching. Okay. A student, maybe he will be attending the class. Please note, these operations are specific to this subclass. Okay. A professor will not attend the class, but a professor will be teaching. So a student will be attending the class. Okay. Now class professor is a subclass of class person, which is a main class. Okay. This is inheritance. Now what is the benefit of inheritance? Or to put it in other words, how can we define inheritance in a more formal way? So as you can see, inheritance, we can have subclasses. So we can have subclasses, so which are deriving, okay, which are deriving or acquiring the properties that are there in the main class, and also adding their own properties, adding their own actions. Okay. For example, class student is taking the name and age from class person, because student is also a person. Along with that, some things are unique to a student, like USN uniform, that is being added here. Professor in a college, okay, he is also a person, meaning that this subclass is inheriting from this main class person. So a professor will have name and age. Along with that, few things are unique to a professor, like employee ID and PAN number, that is being added here. Okay. So we have represented the inheritance relationship in this design. Now what is the use of this while creating an object? Okay, so that is what we need to experience. For example, I will create a student object. I will take the same example, that is for the student class, I'll create an object by name Anil. Okay. So what is this? Student is the class. To be more specific, it is a subclass, but I will write it as a class now. What is Anil? Anil is an object, an instance of a class. As explained previously, once you create an object for a class, whatever attributes are there, whatever operations are there, it will be automatically taken by the object. The object will take it. For example, Anil object will take whatever attributes and operations are there in the class student. What is the reason? The reason is Anil is an object or instance of the class student. So what he will be taking now? So he will take USN uniform, why the attributes USN and uniform were taken by Anil object? The reason is USN and uniform belongs to the class student. Okay. Similarly, he will take this attend class. Now, do you think it's complete? So the answer to this question is no. Still the object is not complete. What is the reason? Please note, class student was a subclass. Subclass of what? Subclass of the main class person. Meaning that whatever was there in the main class, whatever attributes were there here, whatever operations were there here, so that will also be taken by Anil object. Meaning that, so Anil object will take name, age. Okay. For example, there is something like walk, run. So that will be taken here. Now you may ask a question, why name and age attribute was taken? Name and age were not there in student, but still it came to Anil object. From where it came? So this was because of the inheritance relationship that we have created in the design, where exactly the class student is a subclass of the main class, that is class person, because of which name and age came to the Anil object. Okay. So these were the attributes for Anil object, and these attributes can have values as already mentioned. For example, so name equal to Anil, age equal to maybe 20, USN equal to maybe some 4 mH, some stuff. So uniform color, something. Okay. So we are ready with Anil object. All the details of Anil are there in this object, and it can be used for further processing, for further computation. Okay. Now, as mentioned, do you think Anil is the only object that you can create? No, you can create hundreds of objects here. You can have hundreds of students. Each student represented as an object, which is an instance of a class student, deriving from a main class, that is class person. And this is the power of inheritance. Okay, this is a major benefit of inheritance, wherein which you can have n number of subclasses, taking or deriving from a common main class. Okay. So few things which are common to all these subclasses, things which are common to a student, professor, like name, age, you can stuff it in one main class. You need not repeat it in each and every subclass. I need not write name, age in student. It's not needed. I need not write name, age in professor. In turn, we are saving space and computation cycles. Okay. This is the reason why object-oriented approach became very popular. As I repeatedly am mentioning, see, object-oriented approach was popular and is popular and will be popular for a reason, and these are the reasons that you can directly visualize. Okay. The next characteristics of object oriented approach. Is what we call as polymorphism. Okay, so what is polymorphism? So poly is an English word. What does it mean? Different behavior. Okay, behaving differently. Many. Poly means many. Okay. Morph means different. Okay, so polymorphism means behaving in different ways, behaving in different forms. Okay. Now, can this quality have an impact on object-oriented approach? Okay. Yes, definitely we will go through it. Before that, I'll give you some real-time examples so that you can get some perspective about it. Okay. For example, our Anil, just now I took an example of Anil. Anil as a person, okay, when he comes to college, he is a student. He will be a student. Okay. Once Anil completes the college, maybe after 4 p.m., once he completes the classes, now he is going and sitting inside a bus. In that case, he is a passenger. Okay. So once Anil reaches home, now maybe he is taking the behavior of a son. Okay. Now you consider Anil's mother has asked him to bring some groceries from store. At that point he is a customer. Okay. Please try to understand the behavior. Okay. Behavior of Anil is changing depending on the situation. He is in college, he is a student. He is sitting inside bus, he is a passenger. He is with his parents, he is a son. He visits a shop, mall, he is a customer. Okay. Please note, a single object, a single class is behaving differently at different instances of time, and this can be one of the best examples, a classic example for understanding the polymorphism concept. Okay. Now I'll become specific to example. We'll see an example. For example, you consider there is a class by name class arithmetic. Okay. This is a class arithmetic. Okay, we will not focus on the attributes. We will just take a few operations. Let us add. Okay, we are focusing on the operations part, actions part, okay, of this class. So we have a class by name class arithmetic. In this class arithmetic, we have few actions or operations. So what is your observation here? What should be your observation? Please note, the operations or actions have the same name, add. Now what is the difference? Difference is in the arguments. In the first case it is only 2 arguments here, in the second case it is 3. Okay. Now function name is same, action is same, but it will change depending on the number of arguments. Now how things may work out here? For example, I'll create maybe an object for arithmetic class. Okay, I'll create an object x. Okay, now x is an object of class arithmetic. So already we have seen what is an object, what happens when an object is created. We have the detailing about it. So based on this knowledge, we will continue with the discussion. So once I create an object x, so this object can access all the attributes and operations that is there in that class to which it is associated. Please note, x is associated with the class arithmetic. Okay, so now I want to call this function add. I want to use this function add. Okay, so I will give like this, x dot add. Okay, I'll give this x dot add. Now which add function to call? Is it the first one? I label it as 1. This is second one, just for understanding purpose. Which one to call? Is it the first add or the second add? Okay. So the answer to this question is, the design will decide upon this based on the number of arguments you are giving. For example, I give 2 arguments, 2, 3. Okay. So depending on the situation, okay, depending on the situation, object is taking the behavior. Please note. Now in this case, what happens here? What the object x will call? The object x, it will call which function? Is it the first add function or the second add function? So the obvious answer here is it will call the first add function with add a comma b. Okay, so this function will be called and it will be executed. What was the reason the first add function was called? The reason is we had given 2 arguments. So based on the number of arguments you have given, the behavior of the has been defined. Okay, the behavior here is calling appropriate function. What if you had given 3 arguments? For example, I will give like this, 2, 3, 5. I have given 3 arguments. Okay, so now the behavior changes. That is what polymorphism is all about. So behavior is decided based on the instance. Okay, Anil in college is a student. Anil at home is a son. Anil visiting a shopping mall is a customer. Okay. So now add function with 3 arguments. So it will access this. So this is the beauty of object-oriented programming, object-oriented approach, where we have mechanisms which are scalable, like how you saw in the previous case. We could create hundreds of thousands of students for one single class, for one single blueprint. Okay, you saw mechanisms where we have sufficient flexibility. Okay, so we can change the behavior based on the need. Okay, so this was polymorphism. So with this we will conclude today's discussion. In the next session we will continue with one more powerful characteristics of object oriented approach called as abstraction.